Hello, everyone. I welcome you all to another session of the Ken Seminar Series. Today, we are delighted to have Dr. Matteo Muratori with us. Dr. Muratori is a renowned expert in the clean energy transition, specializing in climate change mitigation strategies for transportation and mobility systems, as well as exploring cross-sectoral integration opportunities. Dr. Muratori is currently a member of the research staff and founding manager of the Transportation Energy Transition Analysis Group at the National Renewable Energy Laboratory. He holds a bachelor's and master's degree in energy engineering from Politecnico di Milano and master's and PhD degrees in mechanical engineering, along with a minor degree in statistics from the Ohio State University. Everyone, please join me in welcoming Dr. Muratori.
Thank you very much. Can you hear me well?
Yes, we can hear you quite.
Awesome. So I'll take it from here. Thank you for the nice introduction. Over the last month, I've actually transitioned from the National Renewable Energy Laboratory, or NREL, to PNL, the Pacific Northwest National Laboratory. We are located in Washington State. We're very excited to be with you today. I look forward to talking and having an engaging discussion after the presentation. I like to start things from a very high level perspective. And so I'll start talking a little bit about our energy system, and then I'll zoom in to focus a bit more on transportation. And then I'll do a second zoom in and really focus most of the technical part of this talk on electric vehicles. And discuss a little bit different aspects around electric vehicles. But starting from a high level perspective, energy is really foundational to our lifestyle. Imagine what you do on a day-to-day basis and the energy that we use in buildings for lighting and for heating and cooling and for cooking and refrigeration. And think about industry and manufacturing, and think about communications and what's enabling me to talk to you from Colorado to Illinois in a very seamless way. And think about mobility and the way that we move freight all over the world and the way that we move people around the world. So that's all enabled by energy. It really makes a large impact on our life. And you can see here over the last 2.5 centuries, we have consistently increased the amount of energy that we consume to provide all the amazing benefits that I was describing earlier. Today, about 80% of the energy that we consume comes from fossil fuels, petroleum, natural gas, and coal. And fossil fuels are really enabling all those amazing benefits that I described earlier. None of what we do on a daily basis would be possible without what energy is providing us. But like most things in life, nothing comes for free, and there are strings attached. And while fossil fuels have enabled this amazing lifestyle, there have been major geopolitical and environmental implications. I'm not going to talk too much about actually, I'm not going to talk a lot at all about the geopolitical implications, but from an environmental perspective, air pollution kills about 7 million people in the world every year. I let this sink for a second. 7 million people every year. And you have all seen pictures and photos like that where you see water and land suffering from large-scale contamination. And many talk about climate change as our generation's biggest challenge. You see here a chart from the IPCC, the Intergovernmental Panel on Climate Change, and you see what the temperature on our planet would have been under normal condition and what has happened because of our influence on the planet. It is now indisputable that human activities are causing climate change. They're making extreme events, like think about heat waves, heavy rainfalls, droughts, more frequent and more severe. So this is another slide for the IPCC. And there is consensus now that there is no going back to some changes in the climate. We have done too much damage already. However, some of those changes can be slowed down and other could be stopped. And to make this happen, what we need is a very strong, rapid and sustained reduction in the emissions of greenhouse gases around the world. I'll skip this slide. So how are we going about that? How are we thinking about it in the United States? Well, about 3 years ago, a big document was published. It's called the long-term strategy of the United States. You see the cover page there, but it articulates pathways to achieve net zero emissions by 2050. Achieving this transition is going to require very significant changes to the entire energy supply and demand ecosystems. It's going to fundamentally change the way that we produce energy and the way that we use energy across the different sectors. And all the different sectors are somewhat different. You see here in different colors on the right-hand side, transportation in red at the very top is the largest source of greenhouse gas emissions. Then you see the power sector in blue. They used to be the largest source of emission, but you see here between 2005 and 2020, a very steep decline in emissions from the power sector that has already happened. And then you see those emissions projected to continue and really approaching that zero well before 2050 in this plan, while transportation emissions in red do drop over time, but at a slower pace and achieve, sort of get near zero only towards the mid of the century. Then you see industry in green with a significantly slower pace of decarbonization. You see buildings there at the bottom in yellow because they're already heavily electrified, not a lot of direct emissions from buildings. And then you see some carbon dioxide removal or CDR to offset remaining emissions. A key point of this chart is that all sectors are going to need to do their sort of fair share of heavy lifting when it comes to mitigating greenhouse gas emissions. And the evolution of emission reductions in different sectors is going to be different, right? Every sector is different and every part of the economy is going to evolve differently. So now we'll do my first zoom in. We'll talk only about transportation. We're not going to talk about the other sectors today. But transportation is the largest source of greenhouse gas emissions in the country. And the main reason why that is that transportation is probably the most boring sector among all the other sectors of the economy. There is very little diversity in the energy that we use in transportation. Fundamentally is petroleum and a little bit of ethanol. That's what powers transportation in the United States. So this heavy reliance on petroleum, over 90%, about 95% of the energy that we use in transportation comes from petroleum, really lead to this major contribution to greenhouse gas emissions. And it's not only greenhouse gas emissions. Transportation is also responsible for poor air quality, which has a disproportionate impact on some segments of the population in some areas of the countries. Is the second largest household expenditures. So after paying for rent or mortgage, so after expenses for housing, the second largest expense for American families is transportation. So it's very significant element of family budgets. And it is the main driver of global petroleum demand. I've told you I'm not going to talk about geopolitics today, but you all know what that means. And so most of the petroleum that we use, about 3/4 of the petroleum that we use in the country, is used for transportation. So to address the climate crisis, it's clear that we need to eliminate nearly all transportation emissions by 2050. We need to get as close as possible to zero as we can. We're probably not going to be able to hit zero in transportation, and so we're still going to need some of those offsets that we were seeing earlier. But we're going to focus on what can we do to get as close as possible to zero. As I was saying earlier, the US government has put forward this big document that highlights pathways to achieve net zero economy. And there has been a lot of focus and a lot of interest in understanding what could we do in the transportation sector as well. So about a year and a half ago, the Department of Energy, together with the Department of Transportation, the Environmental Protection Agency, and the Department of Housing and Urban Development, came together and published a plan, a blueprint on how are we going to achieve these objectives in transportation. This sent a very clear signal to industry and really set up realistic, achievable pathways based on innovation and science to achieve our goals. Those goals are really articulated. Actually, the strategies to achieve those goals are clearly articulated in this figure. There are three fundamental pillars, three big strategies that the US government has identified to achieve deep emission reduction in transportation. One, we need to start by thinking about ways to improve community design and land use planning to make transportation more convenient. That means, you know, try to minimize the amount of travel that is needed to achieve the objectives that we have, right? So instead of driving for 40 miles to reach your workplace, can we imagine better urban design where you can drive for less or walk and be closer to where you need to be? So how do we think about leveraging all of those solutions to try and sort of eliminate the problem to start with? The less you need to travel, the less you're going to emit. The second big pillar is efficiency. How do we increase options to travel more efficiently? And this includes both shifting travel from more energy intensive mode to less energy intensive mode. So if instead of driving your car, you could take a bus or a train and have the same quality of mobility, or maybe increase the quality of your mobility, that would also significantly reduce energy use and emissions. And on top of that, on the efficiency pillar, how do we improve the vehicle level efficiency? So if you have to travel a mile in one vehicle, how do we make that mile take less energy? How do we make vehicles more efficient? And then the third and last pillar is transitioning our energy sources from mostly petroleum today to clean solutions that include electricity, sustainable liquid fuels, as well as clean hydrogen. So now I'm going to do my second zoom in. We're not going to talk about all of these different boxes. Each one of these boxes could take, the rest of this talk to dive a little bit more deeper into it. All these elements are very important. I'm only going to focus on the third to last one, clean electricity and electric vehicles. I just want to make it clear from the beginning. The vision is not that electric vehicles are a silver bullet and all we need to do to decarbonize transportation is convert from fossil fuel vehicles to electric vehicles. We're going to need to pursue all of these boxes that you see here, but for this talk, I'll just focus on electric vehicles. So electric vehicles have been a revolution in transportation. For over a century, we have only used petroleum, and we now finally have a solution, an option at scale that allows us to do something different. It's the first time in the transportation energy nexus that we can really detach from petroleum at this scale. If you're interested in electric vehicle, one read that I recommend is what's called the Electric Vehicle Bible, the Global EV Outlook, or GEVO, that's published by the International Energy Agency every year. This is the 2020 edition that you see here, only because I really like the subtitle there, Entering the Decade of Electric Drive. This was 4 years ago, and there was still a question mark there. Now the question mark is not there anymore. You'll see in a few slides, electric vehicles have really experienced a significant uptake and significant success. But I really like that subtitle, so I'm not changing that picture. But there is a 2021, 22, 23, and 24 edition of the Global EV Outlook out there that you can go and download for free and take a look at if you're interested. But as I was saying, EVs offer this pathway to decarbonize on-road transportation, which is most of transportation energy use and emissions. Why are electric vehicles so compelling now? Well, technology has matured at an unprecedented pace. Cost of batteries dropped by more than 90% in the last 10 to 15 years, right? And that really enabled electric vehicles to be adopted at scale. There has been a lot of support for clean transportation, and there has been major investments in charging infrastructure. So the infrastructure aspect of converting from one energy system to another are always very important. And so EVs are now a reality, and we expect rapid growth in electric vehicle adoption, both for passenger vehicles, all of you have seen electric vehicles driving around you on the streets, but also for commercial vehicles. Think of buses, think of delivery van. For example, the Amazon van that delivers at my house here in Denver is all electric, as well as for heavy duty trucks and other applications. On-road vehicles are the core applications for EVs. There are going to be some off-road vehicles, some short, small planes, some shipping and ferries that are being electrified in the north, east, and the northwest as well. So some outreach outside of on-road vehicles, but on-road vehicles is really the core application for electric vehicles. Year over year, the sales of electric vehicles keep breaking new records. Last year in 2023, about 18% of new vehicles sold in the world were electric. Over 14 million electric vehicles were sold in the world. You see there, the adoption is really looking like the exponential growth. The uptake of EVs is really growing rapidly. It's driven by China and Europe. The United States is lagging a little bit behind, but one vehicle in 10 sold in the United States last year was electric. So 10% of the market, that's a big number. It's about 1.4 million electric vehicles that were sold in 2023. And that, by the way, is a 50% increase from 2022. So the growth in electric vehicles in the US is very significant and accelerating very rapidly. This is just to give you a sense of what electric vehicle adoption looks like. And it's a very nice quote there. The future is already here. It's just not evenly distributed. There are areas of the countries, look at, for example, some of the counties in the San Francisco Bay Area, where EV adoption is getting close to 50% of the market. So almost one in two of every vehicle sold is electric. But there are also large parts of the countries where adoption is much closer to 0%, or maybe a few percentage points. So when I say 10% of vehicles sold in the US were electric last year, that's a national average. There are areas that are much further ahead in that curve, and there are areas that are farther behind in that curve. So keep in mind that whenever we talk about these big statistics at the national level, those are always averages, and they sort of mask a lot of potential heterogeneities and differences across the country. But not only EVs are experiencing a rapid adoption today, there are very ambitious targets to continue increasing adoption of electric vehicles all the way to reaching phase out for the end of sales of internal combustion engine vehicles. You see what those commitments look like on the left-hand side for light-duty vehicles. For example, California and 13 other states in the US committed to a phase out by 2035. The European Union also committed to a 2035 phase out, some areas in Australia, some Chile as well. So you see around the world, what those goals look like. And on the right-hand side, you see very similar goals and a very similar map from the ICCT for medium and heavy-duty vehicles. So back to the point I was making earlier, not only passenger cars, but also commercial vehicles are transitioning quickly towards zero-emission solutions, and EVs play a big role there. And there are major commitments for a phase out by 2040 for major economies around the world. Also note interesting comments here, but there aren't explicit goals from China, but China is the largest vehicle market today, about 25 to 30 million new vehicles sold in China, and it's also the market where EVs are the most successful. So just an interesting comment there. But keep in mind, EVs are being successful. There is major political support, but it's not only government targets and goals, right? It's not just this ambition and this policy sort of strive towards EVs. There are major industrial investments that support the transition to EV. When I saw this chart, I had to read it twice. I couldn't believe it at first. But last year, electric vehicles overtook renewables in terms of the largest investments in clean energy. So over $600 billion were invested in 2023 in electric vehicles. That is more than solar and wind combined. Okay, so this is a terrific amount of resources and money that are being invested by industry in this transition to electric vehicle. And you see the growth there. Electric vehicles are the green bars. And you can see them in 2015, 2016, pretty small. Notice how quickly it's growing, how fast it's booming. The transition to EVs is really happening at an extremely fast pace. So for the rest of this talk, I want to touch on 5 key points around electric vehicles: sustainability, affordability, manufacturing, charging infrastructure, and the integration with our grid and charging of electric vehicles. So the first question is around sustainability. Are electric vehicles a green solution? Do they really reduce emissions? And the answer is a resounding yes. I think this chart from the Department of Energy makes the point very well. Today, an electric vehicle in the United States reduces emissions by about 50% compared to a gasoline vehicle. That includes producing the vehicles, producing the batteries, using the vehicles. Our grid isn't clean yet. So you see most of the emissions associated with an electric vehicle still come from the fuel, the electricity, as well as disposing of the vehicles. So when we look at the entire life cycle of vehicles, EVs today offer about 50% emission reductions compared to gasoline. And in about 10 years, what we estimate is that EVs will emit about 80% less than the future advanced gasoline vehicles and about 85% less than today's gasoline vehicles. And that is because the power grid is getting cleaner and cleaner. I made a comment early on that slope in electric sector emissions is very steep. Emissions from the power sector are dropping very rapidly because we are deploying a lot of renewables. And as a result of that, EVs will get cleaner and cleaner over time. I'll also add in a bonus point to tie in the next point on affordability. From this same study, not only EVs are already cleaner and will get more and more clean over time, but they also offer about 50% lower lifetime vehicle and fuel costs, right? So not only they are cleaner, but they are cheaper. So are EVs affordable? Well, we are getting there. As I was saying earlier, battery costs have dropped by over 90%. It's a major, significant improvement. And batteries in the US cost about $150 a kilowatt hours today. There is consensus that cost need to get to about $80 to $100 a kilowatt hour for what is called the MSRP. That's the price that you pay at the dealer, the manufacturer suggested retail price. That's the price that you pay when you go and purchase a vehicle, right? So, EVs already offer some cost savings. You buy an EV, it costs a little bit more than a comparable gasoline vehicles, but you save on fuel and you save on maintenance. So over time, they are cost competitive. But it's a really hard case for people purchasing new technology to make an investment that's going to pay off over multiple years, maybe 5 to 10 years. So there is a lot of interest in getting EVs to a point at which you can step into a dealer and you look at the gasoline version of a vehicle and you look at an electric version of a vehicle and they cost the same. And for that to happen, batteries need to reach about $80 to $100 a kilowatt hour. So we're working on it. We are getting towards that goal. We're not quite there yet, but it's quite interesting that there have been studies that came out this year that show how China has achieved about $75 a kilowatt hours in 2024. There has been a significant fall in raw material prices globally, which coupled with some manufacturing overcapacity in China has led to a significantly lower cost of batteries. About 2/3 of the EVs that are available for purchase in China are already cheaper than the equivalent gasoline version. So in 2/3 of the cases, you already go to a dealer in China today and you find EVs that cost less than gasoline vehicle. So we are not quite there yet in the US, but we are getting there. The third point is manufacturing. Decarbonizing transportation is a major opportunity to transform a very large sector, and it has really far-reaching implications. The automotive industry is extremely large. In the US, we produce about 10 million vehicles every year, and we import between 5 and 7 million. This is about 3% of our GDP and about 4.3 million people employed just in the automotive industry without thinking about the maintenance and all the oil change and tire rotations and whatnot that come along with automotive and the fuels that are consumed by automotive. Just producing the vehicles employs and the components that go into those vehicles employs over 4 million workers in the United States. So it's a very large industry, very significant for the economy. Over $160 billion have been invested in battery and EV manufacturing plants in North America. And the estimates, this is a study that our friends and colleagues at Argonne National Laboratory did. They estimate that these investments in battery in the United States can supply between 14 and 18 million vehicles annually, right? So the big question is, can we shift this big industry? Can we manufacture enough EVs? And there have been major investment being made at the national level to make sure that we can get there, and that we can produce as many EVs as we need in the country. I'll now shift to my third point. So we talked about sustainability, affordability, manufacturing. One key element for EVs is now charging infrastructure. No one is going to buy electric vehicles if they cannot charge it. This is a nice survey that was done earlier this year by friends at UC Davis, and survey results show that 6 in 10 Americans who aren't yet sold on EVs were concerned about where and when they could charge. Right, charging is a big deal. Again, if you can charge conveniently and affordably, you're not going to buy an EV. So our vision is that what we need to do is develop a charging ecosystem for both personal vehicles and commercial vehicles that increases convenience. The key word here is that we don't need to replace what we do today with gasoline and diesel. We need to provide solutions that are more convenient. And I'll give you an example. I have an electric vehicle and I park it in my garage, and the vehicle charges overnight. And that takes zero effort on my part. It's just such a more convenient solution than having to go to a public charging station or to a gasoline station. So keep in mind that convenience is fast and slow. In my case, charging slowly overnight while I sleep is the most convenient way of charging my EV. I don't care how fast it is, as long as it's charged by the next day when I have to leave in the morning. That charging is extremely convenient. It's also very important to remind people that the infrastructure needs to be accessible, reliable, affordable, and we need to plan for peaks and extremes. So there is a lot of work and a lot of research that involves these aspects. Professor Contu did her postdoc at NREL in my own group, and she spent a lot of time thinking about this. But if you're thinking about research topics in this space, thinking about charging infrastructure is definitely a big deal and a big area of research. Again, keep in mind, EV charging will be heterogeneous. There will be a variety of solutions. And this nice pyramid from the National Research Council makes the point very clearly. It's not going to be a replacement of gasoline stations. There is going to be a lot of different solutions, but the base of the pyramid, really the big chunk of charging, is home residential charging. Charging at home where vehicles are parked for long periods of time with slow chargers that are already available, and just plug in your existing outlet, or maybe you upgrade the circuit to something like what you have for a cloth dryer, and charge vehicles a little bit faster that way. It is what we expect. It is what's mostly done today, and what we expect will remain sort of the base foundation of charging. Workplace is the second largest opportunity. Again, places where vehicles are charged for extensive periods of time and they just sit there. If you can use that time to charge vehicles, that's the win-win. That's the key solution to make it very, very convenient. And then you have a tip of a pyramid there, and that's where you have the fast charging networks and the fast charging stations. We need those. We need those to cover long trips. We need those as a safety net. We need those for people who might not have any other options. But that's the vast minority of charging. About 95% of trips are shorter than 30 miles, right? So we do take some long distance trips sometimes, and we need a fast charging network for those trips, but those trips are the very vast minority of the way that we use vehicles today. Um, as a side comment here, this is a light duty vehicle paradigm, this pyramid. A very similar breakdown applies for commercial vehicles. Think of buses and trucks. Instead of home, read a depot. Wherever the vehicles are parked overnight for long periods of time, that's the opportunity to charge vehicles. That's the best opportunity to charge vehicle. And then you have loading and unloading opportunities and places where in general vehicle are stopped. That's where you want to charge them. But then of course you're going to have again a tip of the pyramid for the high power charging for long trips. And as a safety net, that's always important, is very visible, but it is the tip of the pyramid. So don't forget that. And now I'll transition to my fifth point, vehicle grid integration. You know, we need a charging network to charge vehicles. It needs to be convenient, it needs to be accessible, but we also need to have enough electricity to charge vehicles in an affordable way. So EVs are really poised to drive growth in electricity demand. Electricity demand hasn't grown for the past 20, 25 years in the United States. It's been pretty stagnant. The total amount of electricity that we consume has remained more or less the same. And so, pushing for significant growth in that electricity demand will require investments in generation of electricity, transmission of electricity, as well as distribution systems to then deliver that electricity to vehicles. So we need to make those investments, but there are two key elements here. One, EV offer opportunities to better utilize the power system. And the cost of this infrastructure is spread over more electricity sold. And so what the California Public Utility Commission has found is that looking at the last couple of years, EV drivers have contributed about $800 million more in revenues than associated cost. So they have actually reduced the cost of electricity for all consumers, right? So as you use more electricity, you can spread cost over more units of power sold, and you drop the cost per kilowatt hour. So this opportunity to better utilize assets is a key element of EVs. The second big element is that vehicles are highly underutilized assets. Like vehicles are parked about 96% of the time, and they're only driven about 4% of the time. And this opens up a unique opportunity to provide what we call demand side flexibility. And this is a crucial element for future renewable dominated electricity system. I'll talk a little bit about both of those points. So first, will the grid be able to support widespread EV adoption? Well, we looked at how much electricity would be needed to power electric vehicles if every new vehicle sold was electric. So if we were only to sell electric vehicles, how much more power do we need every year to keep up with that increase in demand? And then we compare that with the historical additions to the grid. And those are the bars in this chart. The red line is the power demand to support 100% EV adoption, and the bars is what we have done in the past. So the key point here is that we have deployed electricity generation capacity in the past at rates that are higher than what we will need to do to support a full transition to EV. So that doesn't mean that we have that capacity. We need to invest. We need to build generation capacity. We need to build transmission capacity. There are going to be areas of the country that are going to experience congestion for transmission and distribution systems. And so we'll need to expand those systems. But the point is, we have done it in the past. And so we are confident that we can do it again in the future. To make it happen, what we need is very proactive planning, as some of these investments are made decades in advance and requires many years to be deployed, right? So we need to plan now for 5, 10, 15 years into the future. So it's really critical that we think about electricity investment with a very close attention to electric vehicles. And now I'll talk a little bit about the demand side flexibility. The power system is significantly changing. Traditionally, the way that the power system has operated is that, we have been dispatching central generation to match demand. At every point in time, electrical engineers know this very well. At any point in time, the amount of electricity that we generate must match the amount of electricity that we consume. Right. So the way that the system has operated in the past, or in the way that it mostly operates now too, is that whenever the demand changes, we shift the supply. We produce a little bit more power, or we produce a little bit less power, so that supply and demand keep in balance. Well, the power system is now undergoing a massive revolution where we are deploying a lot of what we call undispatchable renewable power sources, solar and wind especially. You can decide when the wind blows, you can decide when the sun shines, and you can't regulate, you can't dispatch supply the way that we do with fossil fuels. You can burn a little bit more natural gas, you can't have the sun shine a little bit more. And so you lose flexibility on the supply side of the power system. And what electric vehicles offer is an opportunity to add back flexibility into the system on the demand side. Well, if I can't regulate when I produce energy, electricity, can I regulate when I consume it? And the big answer with EVs is like, yes, there is a huge opportunity space there to decide when, where, and how you charge electric vehicles because they're parked for so long. You only need to charge for a couple of hours a day, maybe even less, but they are parked for 20 hours a day. So that opens up for a terrific opportunity to integrate the two sectors and bring benefits both for vehicles that now can charge at a lower cost and power systems that now can operate at a lower cost. We have looked into this extensively. There are, probably thousands of scientific publications in this space. This is a literature review that summarizes some of the findings, but there is very significant value that can come from managing electric vehicles charging. You see there, up to thousands of dollars per year per vehicle in value in reducing both power system investment costs. This is the cost to build power plants. The way that these power plants are operated, we can make them operate in a smarter way. We can reduce renewable curtailment. That's the electricity that we produce from renewables, but we have no use for, and we just throw it away. And so the least we waste, the better, and the more we can reduce curtailment, the better. We can reduce investments in distribution system. We can increase the number of EVs that be supported by existing distribution system. You see that on the right. If we charge EVs in a dumb way, or if we don't manage EV charging, we can only add so many EVs to any given system. But if we charge them in a smart way, we can significantly increase the amount of vehicles that are supported by one system, which means, if you can sell more power given a given system, it means that the power gets cheaper for everyone. Again, so a lot of win-win here. So let me get here into the final part of the talk here. I want to leave you with some conclusions. So we talked about sustainability, affordability, manufacturing, charging infrastructure, vehicle grid integration, and I've told you a lot of positive elements. There is a lot of progress. There is a lot of really good and positive stories to discuss in this space. I just don't want to leave you with the impression that we are done. There is no more research need. There is no more investments need. EVs are coming and they will replace gasoline vehicles, and there is nothing else that we need to do. There are still key actions and research needs that we need to enable this full transition. On the sustainability side, there are two key things that we need to do. One is continue to decarbonize the grid. We are on the right track. Virtually everything of what we have installed in 2024 in the US was from renewables. So the power grid is really moving aggressively in that direction, but we need to keep pushing and we need to get to a fully clean power system. We also shouldn't forget that, just cleaning up the grid isn't enough. It reduces emissions by, 80, 85%, but the last emissions those come from vehicle manufacturing. And so we need to clean up our industry, clean up vehicle manufacturing, including innovations in new materials, advanced processing, recycling. But it's not just about cleaning the grid. We also need to clean the way in which we make vehicles. We talked a lot about affordability and how some parts of the country are a little bit further ahead than we are. In the US, we need to continue to drive innovation. In batteries, we need to further reduce cost. We are getting there. We are on the right trajectory. We are just not quite there yet, and we need to keep pushing. We also need to start thinking about cheap charging. Vehicles are becoming more and more affordable. We need to make sure that charging them is also affordable. And one of the key elements when it comes to vehicle cost is always vehicle efficiency, right? So the more efficient we can make a vehicle, the better. And more efficient EVs means that to drive the same amount of distance, you need smaller batteries, which reduce weight, which also improves efficiency and also lowers cost. It takes less charging infrastructure. It takes less electricity supply. So there is a lot of positives that come with making vehicles more efficient. So that's always an area where improvement in energy efficiency are always good. On the manufacturing side, again, this is a very large industry, over 4 million people employed just in the United States. We need to think about robust workforce, robust supply chains, and recycling to ensure that we can both manufacture the amount of vehicles needed and deploy them. Right, there is a lot of efforts going on in making sure that we can deploy, manufacturing plants, we can deploy charging infrastructure, we can deploy electricity generation assets. It's not just manufacturing them, but getting them on the ground and working. Keep in mind, the future energy leadership will not be tied to petroleum. The battleground is rapidly moving to materials and processing of those materials. So there are a lot of very strategic actions being done in that space. And here we need to continue to innovate on new materials, processes, and automation. Again, the industrial sector is transitioning much slower than transportation, the power systems, and buildings. And so we need to keep pushing for innovation in this space. On the charging infrastructure side, there are four key elements. Interoperability and reliability. We need to enable all vehicles to charge everywhere, anytime. Like if you have an EV, you might have experienced hiccups. When I go to a gasoline station, I never wonder whether I'll be able to pump gasoline in my vehicle. And that needs to be the same for electric vehicles. You need to park at a location and know that you're going to be able to charge. That charging needs to be convenient, it needs to be consumer-centric, and we also need to keep in mind that charging affordably and in a secure way, so thinking about cybersecurity is really important. And then last, for EV grid integration, forward-looking planning is going to be critical. Grid-related investments are going to be absolutely important to enable a transition to EVs, and we need to enable smart integration of EVs. There are both technical challenges and market changes that are needed to fully leverage participation of EVs in power markets, and we need to work on tackling all of those elements. So to conclude, really, transportation and energy systems are at a turning point. This is the first time in more than a century that we have a chance of powering transportation with something other than petroleum. And what we envision is a future transportation system that will be optimally integrated with our buildings, with electric grid, and with other infrastructure in a way that enables us to fully leverage, but also fully support renewable energy. It's a bidirectional stream. We need clean electricity, but EVs can also help clean electricity deploy and be more affordable. And ultimately, this would enable us to achieve an economically competitive, secure, and sustainable future for everyone. So we would love to collaborate with researchers and professors at your university, and also we're always looking for talent. So join us, reach out to collaborate, and please feel free to send us emails and inquire about our studies at any point. And with that, let me stop sharing and see if we can get into Q&A.
Thank you so much for a nice presentation. Do we have questions? Yes, Mohammed?
Thank you, Dr. Muratori, for the very nice presentation. I really like how you talk not only about the US and how EVs are being adopted inside the US, but how it is on the world stage, especially in China. So you mentioned that in the US, 1 in 10 of new vehicles are EVs. And I think that number in China is around 40% as of 2024. And these vehicles, like you said, are cheaper than their gasoline equivalent in China and cheaper than a lot of vehicles in Europe or the US. But over, I think, the past year, this market on the global political stage, at least, has been kind of weaponized. And in terms of reaching our targets for global warming by 2030, do you think that fighting back against these vehicles that are made in markets outside of the US is going to really hamper reaching that target? Or do you think that the market here and in Europe is going to catch up in time to meet those requirements?
Yeah, so your statistics are exactly right. It's about 40%. They're now pushing 50% this year of vehicles sold in China. And China has really positioned itself as the leading country when it comes to electric vehicle supply chains, like mostly the materials, the processing of those materials to make especially batteries. It's from an environmental perspective, electric vehicles, accounting for all of that, are still significantly about 50% more environmental friendly than gasoline vehicles. So to achieve our environmental goals, I have really no concerns on the electric vehicles. It is the best solution by far. One of the best things that we can do to achieve our emission reductions goal is deploying as many electric vehicles as we possibly can. You also touched on a couple of very important topics which have to do with geopolitics and industrial competitiveness, and there has been a very significant shift in the last few years. Again, China is extremely well positioned in the space. They have made investments well ahead of other countries. But what we have done with the bipartisan infrastructure law and the IRA's investments have been really mind-blowing in the United States. Again, $160 billion invested just in EV manufacturing plant that would enable us to produce as many battery capacity as we need to power all of our vehicles produced here domestically, right? So there has been a very significant policy shift in the past couple of years around, domestic manufacturing and control of those products. So I think that's going to change very significantly over the next few years as those investments start to play off.
One more small question. I think it was slide 9. You said that transportation accounts for its second place in all domestic spending. Does that include the payments? Because I think that's the biggest contributor to spending, right? Like leasing or monthly installments, or is it just for like recharging? I don't think it's just recharging, right?
Let me show you a chart that answers your question there. Let's see if I can reshare my screen. Can you see my screen again?
Yeah.
Yes.
Okay, so that pie chart over there is from the U.S. National Blueprint for Transportation Decarbonization. It's for 2019. Things haven't changed all that much in the last few years, and it shows what we spend money for in the country. About $20,000 a year in housing. That includes mortgages, rents. But then look at the second biggest expense there is transportation. About 80% of it is purchasing vehicles and other vehicle expenses. Those other vehicle expenses are maintenance, fundamentally. So actually the ownership of vehicles is by far the biggest expense there. Then about $2,000 a year in gasoline and other fuels and oil changes and whatnot. And then the smallest fraction is public and other transportation. That includes, for example, aviation and paying for flying around and things like that. Just to give you a sense of scale, over $10,000 a year on average spent on transportation. We spend $7,000 on personal insurance and retirement. We spend $5,000 in healthcare. So we spend twice as much in mobility that we spend on healthcare.
Thank you.
Can I ask a question, Alan?
Of course.
Yes.
Okay, so hey, Dr. Matteo. So it's Jaden, and actually, like, I'm not from UIUC, I'm from UC Davis, and also I'm from Unreal. I saw your LinkedIn post, so then I just jump in. And I have like two quick questions related to my researches about the VGI. The first is I'm very curious about like how do you think about the renewable energy? Like if we can integrate the renewable energy from the power generation side with much more energy storage system, then this can provide much more low flexibility on the demand side. And also my second quick question was like, you also mentioned about the managed charging, right? So how do you think about the managed charging compared to time of use? Like because recently I reviewed one report said that time of use may create some new peak shadows, so they prefer the managed charging strategies. So these are
Yeah.
my two quick questions. Yeah.
Yeah, so on the first one, we have done a lot of research when I was at NREL in that space, and we really see renewables and EVs going hand in hand with one another, right? They each help each other be successful, and so terrific synergies there, and it has to do with this flexibility. Like fundamentally, it is, you can dispatch renewables, and that's a problem for power system. Sure, you can deploy a lot of storage, but that increases cost. EVs allow you to add that flexibility back at a very low cost, and at a very low cost, because fundamentally, when I get back home at 6 p.m. and I need to leave the next morning at 8 a.m. and I need to charge for an hour and a half, it doesn't really impact me whether that hour and a half is between 7 and 8:30 p.m. or 2 to 3 a.m. Right? It makes no difference for me. And so incentivizing consumers to do something that doesn't impact them in the least is very cheap. This gets to your second question, and time of use rates have been shown to create what I call them rebound peaks. The way time of use rates work is that you pay a certain amount of electricity until a certain time, let's say midnight, and then at midnight the price of electricity changes and it drops. And what people do is that, well, then I postpone charging until midnight when electricity is cheaper because I want to pay less to charge my vehicle. That's what I do at home. Very, very, very common, very well adopted. Problem is that if everyone does it, now at midnight, you add all of these loads coming online all of a sudden, and you create a peak that's even worse than what you were trying to avoid, right? So it is a very well-known fact. I published a paper on this like in 2016. This is something that is recognized. So I don't think the time of use rates and I shouldn't say I think there is pretty wide consensus. Time of use rates cannot be effective when you have hundreds of millions of EVs on the road. They're great when you have a few million vehicles because they don't create that big of a peak. But when you have too many vehicles, we need to do something different, right?
Okay.
That could be, for someone, the price of electricity changes at midnight. For someone, it changes at 1 a.m. For someone, it changes at 2 a.m. For someone, it changes at 3 a.m. Someone call it, real-time pricing. You need new mechanisms. And so I was sort of hinting a little bit at that, but power markets haven't really been leveraging resources like electric vehicles at scale, right? We don't have ways for consumers to participate actively in power systems. Like you're usually a passive consumer. Time of use rates are great now. They're not going to work well when you have a lot of vehicles. We need to find better rate designs, better solution, whether it's aggregators, whether it's different rates, whether there are a lot of different solutions. I think we should explore a little bit of all of those, but that's a great area for research. How do we design a market where EVs can participate effectively and not create problems?
Okay, thank you.
I'm afraid we are out of time. Thank you so much, Dr. Muratori, for a really nice presentation, and we hope to connect with you in future. Everyone, please thank Dr. Muratori.
Well, thank you very much for having me. It was a pleasure. And if anyone has follow-on question or interest on our research, please do not hesitate to shoot me an email.
Yes, thank you.
Have a great day.
Yes, thank you, you too. Bye.